Atmosphere of excitement as Europe's JWST astronomers study climate on other planets. Although the weather and environment on other planets have peculiar characteristics, planetary scientists believe that JWST may find hints that might assist to shed light on the fundamental issue of where do we come from? This image of the star formation process was captured in infrared light by the Near-Infrared Camera, NIR-CAM, on NASA's James Webb Space Telescope. Copyright NASA. The James Webb Space Telescope, JWST, which was launched on Christmas Day 2021, is already revolutionizing our knowledge of planets both inside and beyond of our solar system. JWST is a multifunctional satellite observatory that is 1.5 million kilometers distant from Earth in orbit. As opposed to ground-based telescopes, which have to look out into space through the thick atmosphere of Earth, this provides it a significant advantage. JWST's spectroscopic capabilities enable it to use 5 times as much light as the Hubble Space Telescope, HST, to find minuscule signals from far-off planets. Only a very few molecules, such as water, carbon monoxide, and sodium, could be detected before the James Webb Space Telescope. Jérémy Leconte, an astronomer at the University of Bordeaux in France, made the statement. Numerous exoplanets, those outside of our solar system, have been found by previous missions and studies from Earth, and scientists are already using JWST's special capabilities to investigate the fundamental elements of life in the universe. Astrophysicists were able to observe an exoplanet orbiting a Sun-like star, 700 light-years away, earlier this year thanks to the James Webb Telescope. Astronomers can see the chemistry of extraterrestrial sky thanks to starlight that passes through the atmosphere of the hot, Jupiter-like planet WSP-39b. Since they must see through the CO2 in the planet's atmospheres to detect carbon dioxide on exoplanets from Earth, telescopes struggle to collect this data. A wider variety of chemicals, including carbon dioxide, may be found in the atmosphere of WSP-39b thanks to the JWST telescope. Carbon dioxide in the atmosphere may be a sign that there is biological life on the planet. This absolutely changes the game, said Leconte. We must pay particular attention to planets orbiting nearby stars. This is our finest opportunity to describe their environments. He is particularly interested in the atmospheres of the 7 rocky planets that orbit the dwarf TRAPPIST-1 star, about 40 light-years distant. The planets are in the habitable zone, where the temperature is just right for liquid water to exist. Typically, when scientists make predictions regarding the atmosphere of an exoplanet, they presume Leconte has created a 3D simulator, as part of the Whiplash project, which is supported by Horizon, to conduct testing on model planets with known properties, such as the presence of liquid water. Running these tests on simulated planets is similar to having the solutions in the back of a math textbook. Tests can be done, and the results can be compared with the known features. In the upcoming years, tens of thousands more exoplanets will probably be detected, including those spotted with the new space telescope. If the predictions made by their models are correct, scientists want to know. The 4 biggest planets in our solar system, Jupiter, Saturn, Uranus, and Neptune, may hold some of the solutions to problems regarding distant exoplanets. While the Cassini spacecraft supplied information on Saturn, the Juno orbiter mission offered breathtaking pictures of Jupiter. Earlier, when passing through Neptune and Uranus, the Voyager 2 spacecraft captured photos of their atmospheres. Planetary scientist Lee Fletcher at the University of Leicester said, "We have captured glorious images from these planets, with all these whirling storm systems and candy-colored stripes, which are large-scale weather circulation patterns, but it is just a snapshot of their atmospheres and climates at a particular point in time." 4 enormous beings. Fletcher is the leader of a project called GIANTCLIMES that has put the parts of their constantly changing atmospheres together to better understand climate and weather patterns. They studied the 4 large planets' natural cycles over many years using historical data collected by observatories on Earth. The much-anticipated new maps of these worlds from the JWST have been made possible because to our effort. The 2 furthest planets in the solar system, Uranus and Neptune, nevertheless have a mystique about them despite being referred to be ice giants. Methane, hydrogen, and helium make up the majority of their composition. With these 2 planets, there is a ton of room for groundbreaking discoveries, according to Fletcher. Compared to the better-studied gas giants, Jupiter and Saturn, we don't have methyl sleet. Meanwhile, Neptune may have methane snowstorms, while Saturn is known to have enormous storm systems. Temperature is usually a major factor in weather patterns, with Neptune and Uranus, which are far away, experiencing extremely cold temperatures. With the release of the first-ever maps of the air temperatures high in Uranus's stratosphere, there has already been progress. Surprising seasonal circulation patterns and bright regions above the poles were identified. It also predicts that giant planets, often tidal on their axis, have extremely long seasons. We do see seasons modulating atmospheric temperatures in clouds and precipitations as we do on planet Earth, said Fletcher, but we also see regular natural cycles in the atmosphere that are not seasonal. We're just starting to understand the weather on giant planets. The crew was shocked to discover that the planet seemed to have cooled throughout the summer rather than warmed, despite the fact that Neptune's atmosphere displayed significant storm and weather activity. The opening act for the JWST's arrival is GIANTCLIMES. A comparison of the planets will be possible as the new telescope has already examined Jupiter and will soon shift its attention to Uranus, Saturn, and eventually Neptune early in 2023. We are primarily interested in learning how the climates on the 4 planets function, according to Fletcher. More understanding of the cyclical patterns of climatic variability seen on Jupiter, Saturn, Uranus, and Neptune is anticipated. Even more information about Earth's climate and weather patterns may be revealed through their extremes. Research into exoplanets can also benefit from an understanding of the 4 giants. According to Fletcher, we have a collection of different planetary atmospheres in our solar system that serve as a blueprint for what we may anticipate to observe around other stars. The ultimate objective is to attempt to anticipate weather or climate for all planets, not just those in our solar system, Fletcher said. Perhaps these exoplanetary targets also display similar natural cycles, he said. JWST will provide astronomers clearer views into the sky of planets outside the solar system as well as of planets light-years distant, some of which may have protective atmospheres and planetary conditions favorable to extraterrestrial life. 2 areas of astrophysics are developing quickly. Exoplanets and cosmology are the topics in dispute, according to LeConte, which ultimately boils down to the existence of God and the origins of life. Please think about sharing this post on social media if you enjoyed it.